Hi, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. So in the present video, I would like to share my concept on vector differentiation, and especially today's topic is repeated operations using the operator del. Already we have seen in the previous videos what is the gradient and what are the applications of gradient, and we have done some problems. Similarly, what is the divergence of a vector point function and what is the curl of a vector point function. So all are related to the operator del, and del can be applied on both scalar functions as well as vector point functions. So in this present video, I would like to share my concept on repeated operations using the operator del. So what is del? Del is the differential operator, which is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, and this can be applied on both the scalar functions as well as vector functions. So now I want to define the Laplacian operator del square. So if you consider del dot grad phi, so what is a del? Means it is a vector function. Grad phi is also a vector point function. So on considering del dot grad phi, we will get I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z dot product of I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of phi. So on operating with phi, you will get the second term I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z, and the first differential operator as it is. On making dot product, we'll get I bar dot I bar 1, j bar dot j bar 1, k bar dot k bar also 1, and remaining all are zeros. Then we'll get dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. Or I can write this as dou square by dou x square plus dou square by dou y square plus dou square by dou z square of phi, and this I can written as del square. So this is called a scalar operator. The del square is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Or I can write in sigma notation, this is dou square by dou x square. And this operator is known as the Laplacian operator. So del is a vector differential operator, del square is a Laplacian operator. So if some observations from del square, if del square phi is equal to, if we write it as del dot grad phi, then it is divergence of del dot a bar means div a bar. Here del dot grad phi, that is divergence of grad phi. Divergence of grad phi, if you want to calculate, it is sufficient to calculate del square phi, where del square is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Suppose if del square phi is equal to 0, then phi is said to satisfy Laplacian equation. And in this case, the phi is called a harmonic function. If del square phi, suppose if the value is 0, and clearly it is a scalar value, if it is 0, then phi is said to satisfy the Laplacian equation, and this phi in this case is called the harmonic function. So del square phi is used to calculate divergence of grad phi. Now, I'll do one problem related to this divergence of grad r power m. I need to calculate divergence of grad r power m, and I want to show that the value is m into m plus 1 into r power m minus 2 or del square r power m. Div grad means del square r power m is equal to m into m plus 1 into r power m minus 2. So here, wherever you go for r bar is xi bar, standard notation. R bar is xi bar plus yj bar plus zk bar, and r is equal to magnitude of r bar. It is a scalar function, root of x square plus y square plus z square. Then dou r by dou x is x by r. Dou r by dou x means, so on differentiating partially with respect to x, the derivative is 1 by 2 root of x square plus y square plus z square into 2x. X square derivative 2x, y square derivative 0, z square derivative 0. So 2 gets cancelled. The value is dou r by dou x is x by r. So dou r by dou y, similarly y by r, and dou r by dou z is equal to z by r. Now I am considering grad r power m. So I am proving using this divergence of grad first, then we will see del square. Both are same. We can find like this or like this also. So grad r power m. First I need to calculate the term in the bracket, grad r power m. Grad r power m means, grad means I bar dou by dou x, del phi log. R power m is a scalar function. R is a scalar. R is magnitude of r bar, it is a scalar. R power m means what? R power m means x square plus y square plus z square whole power m by 2. R is this is. And r power m, that means this whole power m, that is x square plus y square plus z square whole power m by 2. So I'm using differentiation with respect to x partially y, z, we will get the following terms is equal to I bar as it is, dou by dou x of I bar dou by dou x of r power m plus j bar dou by dou y of r power m plus k bar dou by dou z of r power m. So what is the derivative? Dou by dou x of r power m. R is a function of x, y, z. So I can write m into r power m minus 1 into dou r by dou x, first term. Similarly, j bar, dou by dou y of this one. This is r containing y term also. This is m into r power m minus 1 into dou r by dou y plus k bar into m r power m minus 1 into dou r by dou z. So now I can replace dou r by dou x is x by r, dou r by dou y y by r, dou r by dou z is replaced by z by r. So I'm substituting here, dou r by dou x is replaced by x by r, dou r by dou y replaced by y by r, dou r by dou z replaced by z by r. Now here the common term m into r power m minus 1, m into r power m minus 1, m into r power m minus 1. It is common term, and by r also common. You can write m into r power m minus 1 into 1 by r outside. Then we will get xi bar plus yj bar plus zk bar. Or this can be written as r bar, and r on writing in the numerator I can write it as m into r power m minus 2 into r bar. This is grad r power m. M into r power m minus 1, and writing in the numerator it is r power minus 1, so r power m minus 2 into r bar. I want to find div grad r power m, div grad r power m, that is del dot grad r power m, that is del dot grad r power m. Already we have calculated m into r power m minus 2 into r bar. So on replacing, on differentiating, we will get, so I can write the sigma, entire term is sigma I bar dot I bar 1, j bar dot j bar 1, k bar dot k bar 1. You will get dou by dou x of m into r power m minus 1 into 1 by r into x. So I bar dot I bar is 1. Same principle, I bar dot I bar 1, j bar dot j bar 1, k bar dot k bar 1. Only you will get dou by dou x of this term, that is x into 1 by r into m into r power m minus 1. So I'm differentiating again. I can write this is m into r power m minus 2. Already I have written in the previous slide only. M into r power m minus 2 into x. So I'm differentiating m constant, r power m minus 2 x, both are functions of x. So we have to go for UV method. So I'm differentiating x with respect to x1, r power m minus 2 treat as constant, plus x you treat as it is, term as it is, and r power m minus 2 derivative m minus 2 into r power m minus 2 minus 1, that is r power m minus 3 into dou r by dou x. So what you will get, m into sigma r power m minus 2 plus m minus 2 into r power, so here I can write m minus 2 into r power m minus 3, and dou r by dou x is x by r, already x is there. So I will go into the next slide, dou r by dou x, x by r. So x by r, I am replacing m into r power m minus 2 plus x into, this is x into m minus 2 into r power m minus 3 into x by r. So I am writing r on the numerator, you will get r power m minus 4, and x into x will get x square, m minus 2 as it is, 1 into r power m minus 2 into m. So I am writing it is, so here I can write m, this is a sigma, sigma means you will get m r power m minus 2 for x term as well as y term and z term, m r power m minus 2 plus m r power m minus 2 plus m r power m minus 2. There exists 3 terms, that is I can write 3 m r power m minus 2, that is the first term. M r power m minus 2, here we are indicating only for x, then y, then z. You will get 3 m r power m minus 2 plus next term m minus 2 r power m minus 4 is common, m minus 2 r power m minus 4 and taking outside, in the bracket you will get x square plus y square plus z square, that is m into m minus 2 into r power m minus 4 and x square and expanding x square plus y square plus z square. So this is equal to 3 m r power m minus 2 plus m into m minus 2 into r power m minus 4 into r square. So this is 3m r power m minus 2, here this two terms are multiplying, you will get this one. Take out m into r power m minus 2 outside, then 3 plus m into r power m minus 2 is common term, take outside 3 here, m already I am taking out, m minus 2 will get, or m plus 1, m into this is m plus 1 only, m into m plus 1 into r power m minus 2, and this is the required result. So here we have calculated as per the procedure divergence of gradient r power m. So instead of doing like, you can do like this only, and also you can apply the del square of r power m. You can find del square of r power m, that also you can do. Del square of r power m means what? Similarly, you can do the same problem by del square r power m. This is alter method. You can do like this also. Del square means what? That is dou square by dou x square plus dou square by dou y square plus dou square by dou z square of r power m. So now I can write it as dou square by dou x square of r power m. That means what? Sigma dou by dou x, again dou by dou x of r power m. So on differentiating, what you will get, dou by dou x of r power m is m into r power m minus 1 into dou r by dou x. And differentiating partially with respect to x, r is a function of x, already we know that r is a function of x, y, z. So I can write m into r power m minus 1 into dou r by dou x. But dou r by dou x can be replaced by x by r. So dou by dou x of m into r power m minus 1 into dou r by dou x is replaced by x by r. Or we can write summation dou by dou x of m into x into r power m minus 2. Del square r power m, I can write by using the Laplacian operator, dou square by dou x square plus dou square by dou y square plus dou square by dou z square of r power m. Or you can use a simple notation sigma dou square by dou x square of r power m, that is dou by dou x of dou by dou x of r power m. On differentiating partially, you get this term. Now, on differentiating again with respect to x partially, sigma as it is, just follow the same procedure. M constant, m right outside. So on differentiating x1 and r power m minus 2 treat as constant term plus x into the derivative of r power m minus 2 with respect to x, m minus 2 r power m minus 3 into dou r by dou x. What is dou r by dou x? X by r. M constant right outside, x derivative 1, r power m minus 2 is as it is, plus x into r power m minus 2 derivative. m minus 2 into r power m minus 3. M minus 2 into r power m minus 3 into x by r, because dou x by dou r. So x is already there. So that is as it is. Summation m into r power m minus 2 plus here m minus 2 into r power m minus 4 into x square. So here x is there, x square. And here r power m minus 3. In the denominator you have r, I'm writing in the numerator r power m minus 4. So in expanding you'll get 3m r power m minus 2 first term. Second term m minus 2 r power m minus 4 fixed terms, and in the bracket you will get x square plus y square plus z square, that will be r square. So 3m r power m minus 2 plus m minus 2, here m is also there, m into m multiplied by two functions, here also m into m minus 2 into r power m minus 4 plus 2, that means r power m minus 2. Now I can take out m into r power m minus 2 and taking outside, you will get 3 plus m into r power m minus 2 and taking out, it is m minus 2, or m into m plus 1 into r power m minus 2 is the required solution. So we can do like this also, by using the Laplacian operator we can do, or by using div grad phi. That means we are operating del 2 times. So this operator is called Laplacian operator. Now we will do some problems, similar problems. Show that del square f of r. What is del square? It is a Laplacian operator. Del square f of r is equal to f double dash of r, that is d square f by dr square, plus 2 by r into df by dr, where r bar is xi bar plus yj bar plus zk bar, and r is equal to magnitude of r bar. So I'll solve this problem. Just to notation, we have what is r bar. The same approach here also I am writing x by r plus yj bar plus zk bar. And what is r? Magnitude of r bar, that is root of x square plus y square plus z square. Then what is dou r by dou x? It is x by r. Dou r by dou y, that is y by r. And dou r by dou z, that is z by r. So these things are common for all problems, like these type of problems. Now del square of f of r, what you have to consider on the left hand side? Del square of f of r. That means what? Dou square by dou x square plus dou square by dou y square plus dou square by dou z square of f of r. So this I can write summation dou square by dou x square of f of r. So I can write, instead of writing 3 terms, I can write the sigma notation. So this is equal to summation dou by dou x of f of r. So in differentiating partially with respect to x, dou f of r by dou x, that means what? F of r derivative, f dash of r, this into dou r by dou x, because we are differentiating partially with respect to x. So summation, so we can write here, so I'll go in the next page, summation, what will we get? Summation dou by dou x of f dash of r into x by r. I think so. I'll see. F dash of r into dou r by dou x. Dou r by dou x is replaced by x by r. Dou by dou x of f dash of r into x by r. Now we use the same approach. Dou by dou x of this one. So I can go for u into v form. U into v form. So I'm using, what is u into v form? F double dash of r. F dash of r derivative, f double dash of r, am I right? With respect to x means into dou r by dou x, and x by r treat as fixed term. I am differentiating, this is u, this is v. U into v form. F dash of r derivative, f double dash of r, because we are doing partially with respect to x, you will get dou r by dou x also into x by r is fixed. Now f dash of r treat as constant term and do integration for x by r. Again it is uv form. So r square r into x derivative 1, u by v form, r square, r into v into x derivative 1 minus x into r derivative dou r by dou x. I hope this is clear. F dash of r derivative f double dash of r into dou r by dou x. X by r treated as constant term plus f dash of r as it is. Now I am differentiating partially with respect to x the term x by r. So x by r derivative it is in the like u by v, denominator r square, v du minus u dv. That means what? R into 1 minus x into dou r by dou x. So this is summation. Dou r by dou x, it is again x by r. It is again x by r. Already x by r is there. So what you will get? F double dash of r into x square by r square. X square by r square. Plus here f dash of r into r minus x into dou r by dou x. Again it is x by r square. R minus x into dou r by dou x is x by r. On replacing you will get this one. That is summation f double dash of r x square by r square plus f double dash of r by r square. In the brackets it is r square minus x square by r. In the numerator it is r square minus x square. In the denominator it is r. So clearly on expanding this for summation, you will get f double dash of r by r square into on summation and expanding x square plus y square plus z square. That is the first term. And second term f dash r by r square into r cube. And for x term it is r square minus x square. For y term it is r square minus y square. Plus z square it is r square minus z square. Clear? F dash of r by r square. This is already r there for f dash of r by r cube. So on the term expanding r square minus x square for both y and z also, r square minus x square plus r square minus x square plus r square minus z square, sorry y square. So this is f double dash of r by r square into this also r square plus f dash of r by r cube into and r square plus r square plus r square. This is 3r square minus of x square plus y square plus z square, that is equal to r square. Observe this, r square plus r square plus r square, 3r square minus of, on taking out x square plus y square plus z square, that will be again replaced by r square. So this r square cancel. The value is first term f double dash of r plus 3r square minus r square, that is f dash of r by r cube into 2r square. 3r square minus r square is 2r square. So this and this also gets cancelled. So f double dash of r plus 2 by r into f dash of r. This is what this is. So I can write a div grad into del square f of r. So this is the required answer. Del square f of r. Here you see this. Del square f of r is f double dash of r plus 2 by r into f dash of r plus 2 by r into f dash of r, which is the required result. So instead of finding gradient then diverse, we can operate single operator as del square, and which is the repeated operations of del on f of r. So similarly we can do another problem also, divergence of grad. So div grad means del dot grad phi. Divergence of grad the function x cube plus y cube plus z cube minus 3xyz. So del dot grad of this function. That means what? Del means del square of x cube plus y cube plus z cube minus 3xyz. So here also we can, wherever you find a divergence of gradient, you can use the del square operator, which is called the Laplacian operator. So del square, to apply, what you have to write? Dou square by dou x square of x cube plus y cube plus z cube minus 3xyz. On expanding, del square is dou square by dou x square of this one. So on writing it is summation dou by dou x of 2 times application, 2 times operation on this whole function. So dou by dou x of this one, 3x square minus 3yz. Dou by dou x of, on differentiating with respect to x, you again x cube 3x square, y cube term 0, z cube term 0 minus 3 into xyz derivative 3yz. So next doing again you will get 6x. Am I right? Dou by dou x of 3x square 6x, and this is equal to minus 0, that is summation 6x. So on expanding this you will get 6x plus 6y plus 6z, or 6 into x plus y plus z. So here also we have used the operator del square. So del dot grad phi, that is also called divergence of gradient. So you can apply it directly. Gradient divergence is equal to del square. Del square is the 2 times operation of del on the scalar point function, and the resultant is 6 into x plus y plus z, which is the required solution. Similarly, you can find curl grad phi, div curl f bar. Those are also the operations of del on repeated functions. Prove that div curl f bar 0. Divergence curl f bar. Curl can be applied only on vector point functions. Divergence also can be applied on vector functions. And phi means scalar function. Scalar function you can apply using the gradient, grad phi. So suppose to prove this result, here also 2 times. Curl f bar means del cross f bar. Div means del dot del cross f bar. Divergence of curl f bar, that is del dot. Curl f bar means del cross f bar. Curl f bar means del cross f bar. So, and we have to show that the value is equal to 0. So divergence is always scalar. The value we have to show that is 0. So for that purpose, let us assume that f bar is equal to f1 I bar plus f2 j bar plus f3 k bar, where f1, f2, f3 are functions of x, y, z, not constants. Then curl f bar. What is curl f bar? Del cross f bar, that is determinant of I bar, j bar, k bar, and the first value del coefficient of I bar, dou by dou x, dou by dou y, dou by dou z. And what is the last row? F bar, I bar coefficient, f1 and f2 and f3. Or we can write this is I bar into, what is the term? Dou f3 by dou y minus dou f2 by dou z. I'm taking out I bar. Expanding the determinant, minus j bar into, what is the second term? Minus j bar into, on discarding this column and this row, you'll get dou f3 by dou x minus dou f1 by dou z plus k bar into, and what is the last term? Dou f2 by dou x minus dou f1 by dou y. This is the expansion of curl f bar. This is the expansion of curl f bar. Curl f bar is a cross product of the vectors del and f bar that can be defined by using the determinant. So using this is the value. Then now what is we have to consider is div curl f bar. So we have to find divergence of this vector. Divergence of this vector means del dot curl f bar. So already I bar, del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with curl f bar. So curl f bar is always this vector, we know that. Curl f bar already I bar, j bar, k bar coefficients. Now I'm doing directly curl f bar, I bar dot I bar 1. So what is the first term? Dou by dou x of dou f3 by dou y minus dou f2 by dou z. Right, that is the first term. Dou by dou x of this value minus j bar dot j bar 1, dou by dou y of dou f3 by dou x minus dou f1 by, what is j bar coefficient? Dou f1 by dou z. Dou f j bar coefficient, dou f3 by dou x minus dou f1 by dou z. And last one, dou by dou z of this one, that is dou f2 by dou x minus dou f1 by dou y. This is the final divergence of curl f bar. So operating each term with dou square f3 by dou x dou y and minus dou square f3 by dou x dou y, those two will get cancelled, and minus dou square f2 by dou x dou z and dou square f2 by dou z dou x. So these two are also gets cancelled, And finally dou square f1 by dou y dou z and dou square f1 by dou z dou y. So all are getting cancelled and the value is equal to 0. So divergence of curly f bar, if you want to find anywhere, simply that value will be 0. Without condition, div curly f bar you can put directly 0. Similarly, you can find another property, curl of div curly f bar. The problem is also there, div curly f bar. So you can see that as an example, how to find a divergence of curly f bar. Already we have seen div curly f bar is always 0. So we see with one example, and here f bar is given this vector, then how to find curly f bar. The curly f bar is nothing but del cross f bar. Del cross f bar means I bar, j bar, k bar as the first row. Second row, I bar coefficient in del, dou by dou x, dou by dou y, dou by dou z, and the last row, f bar coefficient x plus y plus 1 and 1 and minus of x minus y or minus of x plus y. Now I bar into dou by dou y of this one. Dou by dou y of this one is minus 1 minus dou by dou z of 0, dou by dou z of 1 is 0. Dou by dou z of 1 is 0. And next what? Minus. So here you can find dou by dou x, x plus y plus 1 I bar into dou by dou y of minus of x minus y. Right? Next minus j bar into, problem may be wrong I think, x plus y plus 1 I bar 1 minus x minus y. So dou minus I bar is already there. How will we get div curly f bar? Divergence of curly x bar. Divergence of, I can see that curly f bar is equal to 0. Dou square f1 x plus y plus 1 minus of x minus y. I bar coefficient minus 1 and 0. Minus j bar into dou by dou x of this one. Minus dou by dou x of this one minus 1 minus 0 minus j bar into dou by dou x of minus 1. Dou by dou z of this one is 0 plus k bar into what? K bar into what? So see, this is only curly f bar, right? Very good. So k bar into dou by dou x of 1 0 minus dou by dou y of this one is minus 1. So what will get? Minus I bar, and this is plus j bar, and this is minus k bar. This is only curly f bar. Now what we have to calculate is a div curly f bar. Div curly f bar means del dot curly f bar. Del dot curly f bar means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with minus I bar plus j bar minus k bar. So I bar dot I bar dot I bar 1. So that is dou by dou x of this one constant 0, dou by dou y of constant 0. So this value is equal to 0. So what I thought that this is div curly f bar, it is simply curly f bar. First we are calculating the inner term curly f bar. Later on we calculate div curly f bar. So div curly f bar is, because of it is constant I bar dot I bar 1 dou by dou x of minus 1 constant 0, j bar dot j bar 1 dou by dou y of constant 1 0, and k bar dot k bar 1 dou by dou z of minus 1 is equal to 0. So we can say that div curly f bar is equal to 0 always. So what is the first result? Laplacian operator del square, that is dou square by dou x square plus dou square by dou y square plus dou square by dou z square, and this is a divergence of grad phi, that is called del square phi. And second one is a div curl. Here it is already vector function. So and again we are applying divergence, so it is a repeated operation. Now similarly we can show another result. Curl grad phi is equal to 0 bar always. Curl grad phi. This also we can prove in a very simple manner. Curl grad phi. So what is grad phi? So curl grad phi. Curl F bar means del cross F bar. That is the formula. Grad phi is also a vector already. Grad phi is nothing but a normal vector to the surface. So how will get grad phi? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of phi. That means dou phi, dou phi, dou phi. This is grad phi. Clearly it is a vector because it is containing I bar, j bar, k bar. It is represents a normal vector to the surface. So it is grad phi. Now what you have to calculate is curl grad phi. So curl grad phi means del cross grad phi. Del cross grad phi. So del means I bar, j bar, k bar. Del means dou by dou x, dou by dou y, dou by dou z. And what is grad phi? I bar coefficient dou phi by dou x and j bar coefficient dou phi by dou y and k bar coefficient dou phi by dou z. So on expanding the matrix determinant, we will get I bar into dou square phi by dou y dou z sigma minus j I bar into dou square phi by dou x dou z minus dou square phi by dou z dou x. So because all are similar terms, you can write sigma I bar into, because these two values are same, dou z dou y and dou y dou z both are same, the value is equal to 0. So for expanding 0 into I bar plus 0 into j bar plus 0 into k bar, that is entire term is equal to 0 bar. So the last term is curl grad phi. The last result, curl grad phi is equal to 0 bar. So what is the previous result? Div curl f bar is 0. Div curl f bar is equal to 0 and curl grad phi is also 0. So this we can show with one example. Curl f bar, where f bar is equal to gradient of x cube plus y cube plus z cube minus 3xyz. Suppose if it is a simple 1 mark question, then you can put directly curl grad phi is equal to 0. So now I want to show that it is also 0. Curl f bar that is equal to curl of f bar means what is grad of the function x cube plus y cube plus z cube minus 3xyz. I want to prove this also. First you find this is, what is the inner term? I bar dou by dou x of this one. I bar into 3x square minus 3yz. I am writing directly. Del means I bar dou by dou x plus del means what? Differential operator. I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. So in operating del on the function x cube plus y cube plus z cube minus 3xyz, I bar into x cube derivative 3x square minus 3yz plus j bar into dou by dou y of entire term. Dou by dou y of entire term 3y square minus 3xz plus k bar into dou by dou z of 3z square minus 3xy. This is curl of this vector. This is the vector gradient of the given function. So that can be done by using the del operator. On differentiating, you'll get this. Then curl of this one. Then what you'll get? Curl means this is a del cross of that function. Del cross means I bar, j bar, k bar. So del means dou by dou x, dou by dou y, dou by dou z. And last terms 3x square minus 3yz. This is I bar coefficient. And what is y bar, j bar coefficient? 3y square minus 3xz. And it is 3z square minus 3xy. So these are the terms involved in the determinant. So then I bar into dou by dou y of this one. Dou by dou y of this one, that is minus 3x, and minus dou by dou z of this one. Dou by dou z of this one is minus 3x means plus 3x. Minus j bar into, what is j bar into dou by dou x of this one? Minus 3y again. Minus dou by dou z, this is j bar into, j bar means you have to discard the central column and first row. Then you get dou by dou x of this one is minus 3y, this value 0. And dou by dou z of this one, that is minus of minus plus 3y. Similarly, plus k bar into dou by dou x of this one minus 3z and it is plus 3z. Dou by dou y of this one is dou by k bar. Dou by dou y of this one minus 3z minus plus z. So all are zeros, minus 3x plus 3x, minus 3y plus 3y, and minus 3z plus 3z. So all values equal to 0 bar. Because it is a curl, always you should write 0 bar, because it denotes that it is also a vector point function. The curly f bar is always a vector point function. So we have seen three different problems which are applied on the repeated operations of del. One is a div grad phi is one, and curl grad phi is another one, and that is also divergence of curl. That all values we have calculated. One is Laplacian operator, and another one is two different problems, and we have seen the related examples also. So with these I conclude my lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.